Now that's, yeah. Thank you. Okay, the first part of my talk is design work and preparation done at NSCL for this GRETINA campaign. The second big part will be some thoughts about the GRETINA performance for experiments here at NSCL, which I think is also quite interesting. So, starting with the first part, I think most of the slides you already know from earlier talks or from past users meeting. So this is the current configuration we have in the 3 volt, which means if you remove all those wooden platforms, you will see this rail system of the big target chamber. This we can use and mount the GRETINA frame structure. So the colored part are the parts which will be delivered by Berkeley, and we will take care for making here those platforms which can move along the rails and in parallel to the beam line. And this is a so-called loading position, because Ian already told you the loading procedure will be that you always get the array in the position that you can insert your detector horizontally, so this we can easily adapt. Now, there, GRETINA doesn't help a lot for measurements. So here's the top view. When all detectors are mounted, we will bring 1/2 of the sphere to this position. Then we can mount the beam line and all the infrastructure we need. Then we close it. And then the important point, we move it towards the entrance port of the S800, and we cover the pivot point. This is important. So that means we get the full acceptance of the S800, because the target is really in the optimal position in respect to the S800 and GRETINA as well. So here's a more artistic view of the whole thing from the side. And now I make the detailed view and describe a little bit more what we will get in reality. First, of course, we won't get so much detectors as shown in the slides before. We will actually get 4 modules, which will be done at the 58-degree position. So here we will have 4, here 1, and from the other hemisphere the same. And 3 modules at 90 degrees. Another important thing is actually we will have a hemisphere or 2 hemisphere, not quarter sphere as in those designs, which is important if you think about putting auxiliary detectors here, for example, Sega. So this will be much harder, because I don't think that Ian will allow us to cut this part away. Another important thing is the big gate valve. It's always a big hassle to keep any device close to the quad, and you see we have to cut out substantial parts of the frame. But now the first real picture. Ian already showed you the frame from the front part, the bright side. I show you the rear part, and for us it's important to see, yes, we have the space. So here we have really a big circle, so big clearance to come close to the S800, and even here the clearance for the gate valve. So this is going to work out. Now I want to talk a little bit of preparations which are really currently being done here at the NSCL, because you may know that NSCL is going to perform the acceptance test for the GRETINA detectors quad number 4 to 7. And this will happen here. And we expect our first GRETINA here at NSCL, not the first GRETINA, because you know already 3 are at Berkeley, now in the next month. And for that, of course, we prepare the Gamma Lab for those acceptance measurements and the scanning, so the whole program we have to do with those detectors. For you users, it's very important to know that this is giving us already now a very good opportunity to handle to learn how to handle those complicated systems. So I expect this will give us a very smooth operation then in 2012, when we actually make experiments. And here, the last slide for this part is preparations in the Gamma Lab. Well, we are making here the rail system for safe handling. And this here is a real photograph that you have evidence that we are doing something, because we cleaned up and we made a lot of space here to put the electronics for the GRETINA to put the scanning table, so something is happening. This is not a GRETINA detector. Next part. If we are going to make GRETINA experiments at the NSCL, and we have our well-known working house, Sega, the obvious question is, Sega and GRETINA, what is the gain? So here you have some artistic view of both setups. You see the Sega setup, which consists of two rings around the beam axis, one covering this angle area, the other ring is covering this angle area, and here the same for GRETINA. And here are the numbers you already know. So the Sega efficiency at 1 MeV in beam is something around 2.5%, and you will boost this by around a factor of 4 to 10%. Nice, huge gain. Another huge gain is the angular resolution of the systems for Doppler reconstruction. So currently we have something around 2.5 degrees, and we expect with the GRETINA position resolution we will cut it down by a factor of 4 to 0.7 degrees. And also the peak to total is a major improvement with GRETINA. Well, question of course is, will we benefit from all those gains? Or the same question, other words, are our typical Sega experiments really limited by Sega only? So, for the efficiency is obvious. We have 4 times the efficiency in what we measure with Sega in 4 days we get in 1 day. The critical part is simply energy resolution, in-beam energy resolution, which simply means what is our Doppler reconstruction. What do we need for Doppler reconstruction? I depicted here a little bit. We have an excited nucleus. It's moving along some trajectory, and it's emitting a gamma. For the Doppler reconstruction, we need to know the detecting angle of the gamma, the scattering angle or the trajectory of the gamma emitting nucleus, and the velocity. Let's look first for the angles. The particle scatter angle we can measure in the S800 very precisely, 1 millirad. The gamma detection angle in Sega is something around 40 millirad. Now we can cut it down to something around 10 millirad.